Assalamualaikum. Today I'll be going over a code in MIPS for for loops, and it will be simulated in this simulator called DrMIPS. Now this is a computer architecture assignment which requires me to run for loop and provides statistics. The number of iterations will be the last two digits of my roll number. My roll number is 28 2011, so the last two digits will be 11. So I'll be running this for loop 11 times. Now we'll be going over the statements line by line, and we'll see how the values of register changes accordingly as the program progresses. Now here the first statement is move. Move actually moves the value from one register to another. Now this is the destination register and this is the source register. We'll be moving the value from the zeroth register into T0. Now the zeroth register always has a value of 0, so it will move 0 into 20. Now this is a step button which increments the program line by line and moves forward just one line at a time. And so if I press this button, here the T1 has the value, the register T1 has the value of 0. Now in the next line, the statement is LI, which stands for load immediate. Which means we can load a constant into a register. And now this is the register T1 and this is the value 11. Now T1 is the destination register in which we'll move the value of 11. Now after I step here, you can see the value of 11 is being added in the register T1. Now the next statement is start loop, a function which has further three statements in it. Now this function is made for performing a for loop function. The for loop doesn't actually exist in MIPS, so we'll be using branch instructions and jump instruction to simulate a for loop in assembly code. Now after start loop, this first line is branch if equal to. It means that it is a conditional statement. It means that the value of registers given to it is equal, then it will jump ahead or branch ahead to the label given here. Now the value actually states the condition actually states that if the values of register T0 and T1 are equal, then it will jump to this label here. Now this label has nothing here, so it will just terminate the program. Now second statement is add I, which stands for add immediate. It is this add is performing as an incremental value in the for loop, or our designed for loop, as a for loop has a always has a value which it increments like I plus plus. So here it is simulating that where it is stating that add an immediate value. Immediate means a constant value into the register. Now here it says add a value of 1 into the values which are already stored in register T0. After this line executes, it will just increment the value of register T0 by 1. And the last statement here is J start loop. The J is a jump instruction. The jump instructions are unconditional jumps. It does not require a conditional to jump. Whenever the control execution comes here, it will always jump to start loop here. Now as I step ahead, when the branch instruction was executed, here it resulted in a false, so the condition did not met, and it just skip ahead to this instruction here add I. And after this instruction was executed, a value of T0 register was incremented by 1. Now after this, when the J start loop executes, it will just jump to the start loop label. And as you can see, the program progresses in the same manner, and the value of t naught or t0 is incremented by 1 in each iteration. Now it will keep on incrementing like this until the branch, if equal to condition, returns are true. Now this is the last time that this branch condition will return a false. After this, the value of T0 and T1 registers will be equal. So the condition becomes true. And as you can see, as the condition becomes true, it goes over to this exit loop label. Exit loop has nothing under it, so the program terminates. Now, what is required by this assignment is to provide statistics of this for loop execution. Now, the statistics are provided by this button, which is called statistics. Now, the simulation statistics state that a clock period of 930 picoseconds, which means that each clock pulse was 930 picoseconds long. The duration of each clock pulse or each clock cycle. Clock frequency, which is the frequency of my processor, 1.8 gigahertz. Next is executed cycle, which means the total executed cycles required by this program. So this program was executed in total 36 cycles. Execution time. Now the execution time is the total execution time which took to execute this program. Now it took about 33,480 picoseconds for this program to be executed on a processor with a clock frequency of 1.8 gigahertz. Now executed instructions, total of 36 instructions were executed. CPI stands for clock per instruction, clock cycle per instruction. Now it took one clock cycle per instruction, meaning it took one clock cycle for a processor to complete one instruction. These are the statistics for this for loop. Now the next condition for this assignment is to run this loop in the reverse order of digits from my the last two digits of my roll number. So the last two digits are actually 11. So the reverse order will be 11. Will also be 11. So it will provide this same statistics for the reverse order as well. Thank you. One last thing to mention here was that we are using a simple unicycle CPU. Um, which means that the CPU is only able the CPU is not pipelined, so it's only able to execute one instruction at a time.